Section 6.1.31. For a multi-state lottery, the following probability distribution represents the cash prizes for the lottery with their corresponding probabilities. We're going to complete part A through C below. So here X represents the cash prizes in money. The grand prize, which is the probability of 0.000000617, and then 200,000, there's the probability for 200,000. For a $10,000 prize, that's the probability. For $100, there's a probability. For 7 and 4 and 3 and then 0. So for part A, it's asking us if the grand prize is 13 million. Find and interpret the expected cash prize. So if a ticket costs $1, what is your expected profit from one ticket? So if this is the grand prize, then that means over here the grand prize is the amount of 13 million. Okay, and if we want to be able to find the expected, or what is the expected profit? Well, we first need to find the mean. And so the mean is taking the sum of the X values and multiplying it by its probability. So that means we're taking 13 million and multiplying it by its probability. And then plus, we're going to take 200,000 and multiply it by that probability. Plus, we're going to take 10,000 and multiply it by that probability. And then plus, we're going to take 100 and multiply by its probability. And then we're going to take 7 and multiply by that probability. And then plus 4 and multiply by that probability. Plus 3 times that probability. And then 0 times the probability there, which is 0.97370626483. Okay, so when we multiply and add them all together, what we end up getting is 29 cents. So therefore, there is the expected value. Okay, so that is the expected cash prize. Okay, so this means that on average, you will win 29 cents per lottery ticket. So to find your expected profit, you want to subtract the cost of the ticket from the expected cash price. So we have the expected cash price and we want to subtract the cost of the ticket. So that's 29 cents minus $1, which gives us negative 71 cents. Okay, let's take a look at part B. It says, to the nearest million, how much should the grand prize be so that you can expect a profit? Assume nobody else wins so that you do not have to share the grand prize. Okay, now if the expected profit is 0, so if the expected profit is 0, this means that we take the expected mean and subtract 1 and set it equal to 0. And we're going to use this equation to find the grand prize. So what we're going to do is, this is the equation. The equation is, we're going to take u, or the mean, minus 1, and then we're going to equal the sum of the values of x times p of x. Okay, so here we're going to again have u mu minus 1, and then we're going to take these entire values that we have up here. Okay, so I'm going to transfer this all the way down. Okay, and so we're going to be using the same thing. The only thing now is we want to be able to find out how much that we're going to what would the grand prize be. So the grand prize, okay, would be where the 13 million used to be. And we don't know what that grand prize is. But we do know that if we label it, we can call it G, because that's the grand prize. And then all of the other values are going to be the same, because we're going to take the grand prize, which we don't know, times that probability, because that's what it said over here. And then we already know the other numbers for each particular value. So therefore, what we're going to do is we're going to solve this like it's an equation. We want to be able to solve for G. Okay, so what we want to do is, we know that we have the value of the mean minus 1, and then we have, which is equal to G times 0.0000617, and then plus, well, we can add these values from here to here. So when we add them all up, we get the following number. We get negative 0.790195221. So therefore, the equation is the following. We're going to set this particular value here, we're going to set that equal to 0, and then we're going to solve G. So we're going to take that equation, and set that equal to 0. And now what we're going to do is we're going to solve for G. So if we solve for G, we're going to add this number to both sides. So we end up getting G times and then that's going to equal positive 0.7901952221, and then we're going to divide by 0. And that's 617. Same thing over here. Okay, so now we're going to know what G is by plugging that into our calculator. So when we plug this into our calculator, let's see what we get. So we get 0.7901952221, and we're going to divide that by 0.617 there, and we get the following. We get 128,070,538.2, and we want to be able to round this to the nearest dollar, so that's going to give us 128,070,538. So therefore, if a grand prize of approximately 128,070,538 gives us an expected profit of 0 to the nearest million, a grand prize of 129,000 has an expected profit greater than 0, since we're rounding that to the nearest dollar there. Okay, next. In part C, it says, does the size of the grand prize affect your chance of winning? And then explain. Well, we would say no, and the reason why is because your chance of winning is determined by the properties of the lottery. And not the payouts.